This interactive simulation plots the fugacities of benzene toluene mixture, the individual components. That's on the right. The corresponding pressure mole fraction diagram is on the left. And what's important here is that we're interested in the fugacities of the individual components, because when we have phase equilibrium, fugacity of a liquid for benzene in the mixture is equal fugacity for vapor benzene that's in equilibrium with it. Now notice we have three regions on this diagram. At low pressure, this corresponds to vapor phase. High pressure corresponds to liquid phase, and this is the two-phase region. So for liquids, when we change the pressure, particularly for such small changes in pressure, fugacity doesn't change significantly. For vapor, as we change the pressure, if it's an ideal gas, which is reasonable at these low pressures, the fugacity is the partial pressure. So if the total pressure goes up, the partial pressure goes up, and therefore fugacity goes up. In the two-phase region, it's more complicated. And so we're raising the pressure, but we also have to take into account the mole fraction. And the best way to look at two-phase region is to look at the liquid fugacity, because we're at constant temperature, so the saturation pressure is fixed. And for example, the mole fraction of benzene in liquid phase times the saturation pressure of benzene would be the fugacity of benzene if we have an ideal solution. And so the idea of the simulation, we can change the pressure, and that changes the location, this dot on both diagrams. We change the temperature, that changes the bubble and dew point lines. We raise the temperature, we raise the saturation pressures, these curves both move up. And we change the overall mole fraction, then we're going to change this point, and we're going to change these curves, as we'll see when we use the simulation. The other options here is we can just display the PXY diagram to make it a bit bigger, or we can just display the fugacity versus pressure diagram. So here is the interactive simulation. You can see if I change the pressure, I'm moving the point, so I'm in the liquid phase region on the left, and likewise on the right in the two-phase region here, and then vapor phase at low pressure. If I change the temperature, the lower temperature, these curves move down, change the other way, move up, and the region where we have phase change obviously changes. And then I can change the overall mole fraction, which on the graph on the left just moves the black point to left to right. But notice changing the mole fraction changes these curves significantly. So we change the fugacity significantly. If we have more benzene, benzene has a higher fugacity. We'll lower the mole fraction of benzene. We're lowering the fugacity in both liquid vapor phases. And then I can select this just to expand to make it easier to see. And I can likewise expand this curve so that it makes it easier to visualize what's happening.